Alright, so today we'll be talking about rate of change and slope and why this stuff is so important, okay? This next unit is just going to be basically based on a lot of rate of change and slope and just working with and being able to figure it out. Now, I will give you a lowdown of why we need to do this. Okay, now later on in math there's this thing called calculus, and for the longest time a lot of mathematicians had a hard time trying to figure out a certain type of problem, and they were like going, well, you know, if I know that this is, let's say that this was time, let's say that that measured time instead of x, and this was distance. Okay, if you notice in this first part, this person's climbing kind of, you know, at a regular pace, and then all of a sudden they get really steep, so it means they're going faster. They're covering more distance in less time. Okay, so that means they're going faster. So what if I wanted to know what the speed was here? And so that's where it comes into a thing which is called lines. And they found out that they can actually calculate what this this right here, let me draw it. So let me move it over a little bit. There we go. Okay, so they could actually calculate what this speed was, which was represented by this line right here. It's a tangent line, just to break the suspense for some of you guys. And then they found out that they could actually calculate it for different points. So like if they wanted it right here at this end point, or if they wanted it right here at the beginning point, all they needed to do was find the tangent line, and they calculated that way. Now, the reason why this is so important, the reason why I'm talking about this beginning calculus to you guys as beginning algebra students, is because this stuff all involves the same thing, and it's slope. And slope is the rate of change of one variable divided by another. Okay? Alright, and slope is also equal to the change in y divided by the change in x. Okay? Something as simple as that. Now you guys might have also seen this in the past as y1 minus y2 divided by x1 minus x2, and yes, order does matter. You're probably asking yourself that. Okay, or you could also represent the other way, y2 minus y1 divided by x2 minus x1. Okay, and as you can see, I found that out by just looking at this stuff. And basically what it's doing is it's taking this old lineage here. Let me get rid of these. Delete. Okay, and what it's doing is you're actually finding out the key difference between a couple of points. So in other words, let's say we pick a point here and a point here. Okay, and what you're doing is you're actually finding the change in the y-coordinate, which we would call rise. Okay, and then you're dividing it by the change in the x-coordinate, or the change in time. Now, if you look at this in terms of speed, okay, speed on your odometer is measured as distance divided by miles, which makes sense because your distance is your y-coordinate and your time is your x. So this is my x's. Okay? No, not distance divided by miles. Distance is miles. Distance divided by time. I don't know why I wrote down miles. That was weird. Okay, so this slope right here is just finding that. And so what you could also do is you could call this the change in y, and you could call this green part the change in x. Okay, now what most people will end up calling this in lower level math is just this is the rise and this is the run. Okay, but you have to be ready for the fact that later on in higher up math they will switch from one meaning to another. Okay, so just be ready for that. So change in y, change in x, run, rise, same thing. Now what you could also do is go up here and say that slope is also equal to rise divided by run. Okay, Alright, so that's enough talking theoretical stuff about it. Let's actually do some problems. Okay, so what you can do is you can actually find slope between 2 points. Okay, so slope between 2 points. Like, let's say we had 2 comma -5 parentheses 9 comma -1. Okay, something like this. So first off, you have to identify your x's. Very important. Identify your y's. Okay, and then just go ahead and working on them. So it's going to be the change in them. So whenever you're doing change, it's going to be subtraction. So on the top, we're going to have -5 minus the -1. Okay, and then you're going to divide it by 2 minus 9. Okay, you just divide the top by the bottom. Okay, so now this is important here, because when you come up with this double negative, you're going to change that to a positive. So this is going to become -5 plus 1, which is -4, and 2, let me get rid of this parentheses, there we go. So that becomes a -4 on top of the fraction, and then on the bottom, that's going to become a -7. Okay, now if you remember your simplification, if you divide a negative by negative, you get a positive, so it becomes 4/7. Okay, and that's the slope. Now, what is that saying about this problem? All right, in order to go from one point to another, so let's say we went from 2 comma -5 to 9 comma -1, and this should help you with checking your work. Okay, what that 4/7 is saying, okay, that's saying I went up 4 and to the right 7. Okay, to go from one point to another. So in other words, I went right 7 and up 4 to make this 4/7. So here's my 7, here's my 4, and that's to go from this point 2 comma -5 to 9 comma -1. Okay, and you could also say, now that's a part of math that we call a taxi cab geometry. Okay, it's going like along streets and stuff, whereas we usually deal with, as the crow flies type of geometry, we go, okay, what's the shortest distance between 2 points? It'd be a straight line. Okay, all right, so that's what that's talking about. And the cool thing is this actually also explains speed. So we could also explain speed this way and just work with it. Now, you're going to be asked a lot of questions and stuff, and you need to know the difference between them. Okay, so here we go. Let's try to cover as much as we can as possible. Okay, so this way right here, this is positive slope. Okay. If I do a different direction, like let's say the opposite direction, down and to the right, that's negative slope. Okay. Say I went straight across, that is called zero slope. Pretend it is 0, it's not exactly 0, I went up a little bit at the end. Okay, and if I went straight up and down, this would be called undefined slope. Okay, undefined. No, undefined. There we go. Okay, so those are the 4 types of slope that you are going to get, and they all have their own unique things, especially in their equations. So this is going to be like y equals some positive number times x plus some other number, you know, so on and so on. But the important thing is that this slope is going to be positive, this slope is going to be negative. Now these type of lines, these are going to be known as y equals some number, and it's literally just a number. And usually it's going to be where you cross the x-axis or the y-axis. Okay, and then this one, the undefined one, most people forget, is it's just x equals a number, and that number is usually where you cross the x-axis. Okay, so as long as you pay attention to those, finding slope and writing them into the formulas should be pretty easy. Okay? All right, and remember, when you're using tables, it's just the same way. You just use the same formula. You find two y's, you subtract them, and then you find the same two x's that match up with those y's, and you subtract them in the same order as well. And when you do that, you just make your job a whole lot easier in trying to find the rate. Okay? All right? So that's it for rate of change and slope, and I just explained where we get it from, especially from calculus. So I will talk to you guys later. Bye.